Well, the day has arrived. We're going to be trying to get this IBM PS2 Model 25 from 1987 connected to the modern internet. And we're going to be doing this with the Western Digital EtherCard Plus, also called the 8003E. It was originally released in 1987, and at the time it was a fairly inexpensive card at $399 compared to other cards at the time like the Exos 205T, which was over double that at nearly $900. One of the reasons it was so much cheaper, other than it being a much simpler card, was because of this chip in particular, the National Semiconductor DP839. We'll be doing a deeper dive on these early NICs on the serial port, so be sure to subscribe over there if you want to catch that in the future. All right, so before we can get the card installed, we need to make sure we have the jumper configuration set up correctly for the system. And so we're actually at the RetroWeb, which is kind of a volunteer-run website, if you haven't seen it, that is a huge database of retro and some current hardware. And they catalog everything from motherboards to CPUs, expansion cards, and everything in between. And so it's a really great resource that we try to contribute to when we can. And it's helped us out a number of times, and it's run by a group of really great people, and they have a very active Discord that I'm on. Everyone there is very helpful if you have any questions, and it's just a really great community that we are happy to contribute to when we can. And so what we're going to do is go over to the expansion cards. And our card is a Western Digital, of course. And you can see here it's actually listed as an SMC, and this card shown here is actually this exact card because I contributed the photos for it. And Western Digital actually sold off their NICs and I believe their floppy controller division to SMC at some point in the late 80s, maybe early 90s. But the WD8003E, which is the card we have, was originally developed by Western Digital. And what we can do is go over to the documentation tab and click on MTL Jumper Manual. And for a lot of the cards and motherboards on RetroWeb, they have these great PDFs that have the jumper configurations and other information that can be really helpful. And so what we're going to do is just go through here and just make sure we have the jumpers set up how we want. So our first jumper is going to be W1A, which is this block right here, and it's the leftmost jumper. So we're going to be looking at this jumper right here. And we can see that on the card right now, it's open. And there's a note here that says this jumper is ignored in an XT class machine, which is what we're installing it into, so we don't really have to worry about this. And so our next set of jumpers are going to be the B through E positions in the same block, and this sets the IO address for the card. And this little I with an accent on it denotes that it's the default for the card. And so if we look on the card itself, we can see that right now it's configured as closed, closed, open, closed. And that actually corresponds with the default value here of 280H. So we have closed, closed, open, closed. So nothing we need to do there. I believe we set the XT-CF Lite to an address of 300. So that just means that we're not using the same address as the CF Lite, which is great. So then our next set of jumpers are going to be for the IRQ. And this is going to be W2A through F. If we look on our diagram up here, it is the bottom block of the card. So this one right here. And for IRQ3, the B position should be closed and the rest should be open. And if we look here on the card, that's exactly what we have. So we have open, closed, and then the rest are open. And so that means this card is using an IRQ of 3, which is the default. So no surprises there. And our next set of jumpers is going to be W3A through F. And back up here in the diagram, we can see that is this block right here. So these are all closed on the card currently. And if we look on the definition here, we see that if they're all closed, it's using the 10^2 coax connection, right? Our BNC connector. So what we need to do actually is take all these jumpers off as we want to use the AUI because we're going to be using an AUI to RJ45 transceiver. And so what we can do is just pull all the jumpers off. So now we should be set to use the AUI port. And our next jumper is going to be W4, which is the Ethernet version. And back up here, we can see that W4 is the single one. So it's this single jumper right here, which is open on the card. And so we can see that the default is open, which is what the card is set to. And that is compatible with 10 base 2 or 802.3 version 2, or what's called Ethernet 2. So that's fine. So that's exactly what we want. And then our last jumper here is for segment length. Now, we're not concerned about that at all, but we can just see what it is set to. So W5, so that's this jumper here, and it's closed on the card. And that's the default. So a maximum length of 185 meters. So again, not anything we need to worry about in this situation. So with that, it looks like our card is set up and ready to be installed into the Model 25. So nowadays, probably the most popular option for getting DOS on the internet is using something called MTCP. And it's a group of applications that are built using a common TCP/IP library, and it's still actively developed to this day. And they have everything from FTP, FTP server, a web server, IRC, and then it's kind of simple tools like ping and telnet. And so what I thought we'd do is just go ahead and download a couple of these. And then we also need to get something called a packet driver, which we'll talk about shortly. And so what we can do is just download all of these packages. So if we scroll down here, we can just get the standard binaries here in the zip file. Okay, and with that downloaded, we also need something called a packet driver. And a packet driver is essentially just a device driver for DOS. It allows the TCP/IP applications to communicate with the NIC that we have installed. And on the MTCP website, they actually have a collection of packet drivers here. And I think the one we want is down here. And yeah, so we can see down here, we have the Western Digital /SMC 8003 series, which is exactly what we have. And it's just a .com file. So these are actually TSRs, so these will run in the background. And so we'll go ahead and download this because we'll definitely need that. And then I've also really been wanting to try out a web browser for DOS, and I'm not sure if it's going to run, but I wanted to try out the micro web browser. Most of the browsers that are for DOS tend to kind of require like a 286 at minimum. And so the 8086 and the Model 25 might be kind of pushing it, but we'll go ahead and see if we can actually get this to run. And so we want to get a pre-built binary here. So go to releases, and yeah, I think we can just download that. And so there's another FTP stack that's popular called Waterloo TCP or WAT TCP. And when I was doing some research for this video, I stumbled across this web server called EasyNOS2. And it's actually based on something called KA9Q, which was a very, very early TCP/IP stack for DOS. And it was actually meant for packet radio, but people have adapted it to different applications. And so EasyNOS2 here is a FTP and web server that runs on 8086s. And so I wanted to give this a try as well. And I had to actually access this website through the Wayback Machine through the Internet Archive. So I thought it'd be cool if we gave this a shot as well in case the web server from MTCP ends up not working. So before we actually get started on running the applications, we need to also create a configuration file for MTCP. And it kind of starts first with setting an environment variable that MTCP looks for to actually determine where the configuration is. And so we'll set that up on the system itself, but down here, we need to create kind of a basic configuration file. And so the first line we need is going to be to define the packet driver interrupt that we choose. And so kind of the standard to use is 0x60 or 0x62 in hex. So why don't I go ahead and create a new configuration file here. And so we'll just use 0x60. And we're not going to be using DHCP because I use static IPs on my network. Let's see down here. Yeah, so we have these right here. So we have host name, IP address, net mask, gateway, and name server for DNS. So why don't I just go ahead and copy that, and I can paste this in here, and then we can update this. And so we're going to use an IP address of, let's say 10, net mask is good, change gateway, and change name server. So that should be good. And so we're going to save this in the MTCP directory as MTCP CFG. Okay, so we've booted into DOS 3.3, and I've loaded MTCP, microweb, EasyNOS2, the web server, and the packet driver. So let's go ahead and try running the packet driver here. And yeah, it looks like we need to specify the packet driver interrupt that we're going to use. And so in our configuration file, we specified 0x60. And so that's what we're going to specify here. And we shouldn't need any other options on here. So let's go ahead and give this a shot. And yeah, it looks like it worked. So it found our IRQ of 3, IO port of 280, which were the defaults for this card that we have configured. And yeah, it found the card and looks like it is working. So that's great. So why don't we go ahead and go into MTCP, or actually no, before that, we need to set the environment variable. And let me refer back here real quick. So yeah, it's going to be, let's go into the MTCP directory, make sure our config is there, which it is. We're going to set MTCP CFG equals. And I think we might be ready to go from here. So let's go ahead and try to ping. So this is the first time this machine has been on the network. So we'll see if this works. Oh no, we have a problem in our config file. So too long. All right, so we're going to attempt to use Edlin, the built-in editor for DOS 3.3. Why don't we just try maybe erasing this line? Okay, so let's try that. So I just deleted that line. So we'll try this again. It's working. Oh my God. Wow, that's amazing. So yeah, we are on the network. We don't have a name server though, so I can't ping Google, for instance, because we had to delete the name server line. So I wonder why that isn't working. All right, so let's try this again. I'm gonna become an expert at Edlin. I got to do it this way. Yeah. Okay. So now let's try this again. So we know regular ping is working, so we can ping the router. So now let's try Google. Oh my God, we're on the internet. That's amazing. So we're pinging Google from a Model 25 from 1987. That's amazing. Okay, so let's see if we can telnet. Okay, so we're gonna telnet to, see if we can telnet to BBS here. Oh, amazing. Wow. Let's leave feedback. Amazing. Okay, so now that we are on the internet, so we've completed our goal basically. I wanted to get this machine on the internet. It's on the internet, and we've pinged Google, and we've actually connected to a BBS. So I really want to try microweb. So let's see what it takes to get that working. So let's get out of here and go into microweb. And let's see. So I don't know how to use this at all. I'm just going to try running it. Network interface initialized, so that's good. So we have MCGA, but I don't think that is supported. So I think we should try, let's see, we'll just go with CGA for now. Oh my God. All right, let's try 68K news. No way. This is insane. It's pretty slow, but we are web browsing on a system from 1987. So this is before the World Wide Web was even a thing, maybe even a concept, and this system is now on it. That's incredible. Keyboard shortcuts. All right, escape is exit. Oh, there we go. That was easy enough. Okay. Wow. Okay, so microweb actually works. So let me actually go back in here again. Let's see what type of website we can actually visit here. Can we do composite CGA? I wonder. Okay, looks like it might be working. Let's try serial port. It is very slow. It does run, but it is quite slow. And I'm not sure if we're going to be able to... Oh yeah, we are loading the site. It's very broken. So if we go under IBM, yeah, it's quite slow. It's not responding to any of my inputs. We'll do a reboot. Okay, so looking at the configuration for EasyNOS 2, it looks like it tells us how to set up a packet driver, which we already have. And let's see, it's saying it's read by the attached statement in autoexec.nos. And yeah, this is what we're going to need to edit. We may need to edit the batch file as well, but let's take a look at this one. Okay, yeah, so we'll be definitely modifying this. I think it's going to be easiest for me to just FTP this over. So I'll edit the default file and then we can just FTP it over, utilize our new FTP and Ethernet capabilities. Okay, so looking at the batch file here, yeah, so we don't need to do this because we already have one running, right? So, and we don't want to shut it off when the web server shuts down. So that looks fine there. Okay, so here we'll change this just to our IP address. That looks good. Down here, the packet driver is going to be 0x60. And that looks good. We need to change our gateway and name server and change the SMTP, even though we don't have that. And we will go ahead and save that. And yeah, this is just like directory stuff. We don't need to change any of that. Okay, so let's try the FTP client. I have a server running on my machine. Yeah, there we go. That's amazing. So we want to grab the batch file. We got that. Go into Etsy and get the auto exec. Perfect. So I should have both of those files there. I do. So if we go into Easy NAS, let's just move to, can I just do that? Move? Nope. Okay, we can just copy. So we need to, let's delete and then copy. Okay, and then in Etsy, we will delete the autoexec.nas and copy the one from. Perfect. All right, so let's go ahead and try to start the web server now. So I'm going to run the batch file here. Nothing's happening. Waiting. Okay, we got a reboot, so let's see what's going on. May have messed something up in the batch file. Ah, yes, okay. I see what I did. So we actually need to run the 8086 binary instead of this one. So what I think we'll do, let's see if we can use Edlin this time. So we want to, why don't we just delete 10 and then okay, I think this maybe should work. So let's try this again. Whoa. Okay, I think it might be running. Yeah, here are our commands. Let's see if we can we ping Google? Yes, we can. It's working. All right, so maybe the web server is running right now, possibly. Let's try it. So if we go to the IP address of this machine, I think it might work. That's amazing. Oh my God, that's incredible. Wow. Yeah, we definitely need to do some benchmarking and see what kind of performance we can get out of it. Okay, so we're going to try using a tool called Apache Bench. It's a real simple tool that's going to allow us to just kind of get a rough idea of what kind of performance this 8086 system can reach. So the options we're going to specify here are the number of requests and the concurrency, meaning how many requests at a time we're going to make. And let's see, so we'll just start with something like 1,000 and we'll do 10 at once. And then I think we just put in the host name, right? Yeah, so. Oh, looks like we need a path, so. Here we go. Still responsive. But yeah, and we can see at the top here, we're getting some changing values. I have no idea what those values indicate. Okay, this is taking quite a while, so let's stop this and see what we can determine so far. Wow, we'd only completed 148 requests and it took over 530 seconds. Okay, let's try a total of 30 with doing 10 concurrently, see what happens with this. This is extremely slow. This is insane. So request per second, 0.28. Wow. So let's try something like this. Instead of trying to do concurrent requests, we'll just say 30 request period and just see what happens. Okay, yeah, so looking at the status bar here, it looks like HTTP equals may be signifying the number of connections. Since we are doing a concurrency of 1, we're now seeing HTTP equals 1. And I wonder if I change that to concurrency of 2, for example, if that number will increment to 2. Yeah, so our request per second is slightly improved, and so is our transfer rate. So if I change this to 2, yes, okay, so we have, that is the concurrency. So it looks like the max we're able to support, like if I try 10 again, 6, yeah, so we're maxing out 7. Looks like 7 might be the absolute limit of what we're able to support. And it drops down as much as 4. And averages out around, yeah, 4 to 5, something like that. Wow. So while we're doing that, let's see if I now try to reload, how slow the site is. Still waiting. Okay. It loaded. Wow. Yeah, that took quite a while. So let's try to quantify that. So now if I refresh, wow. So it took nearly 19 seconds to reload while the benchmarking tool was running. That's incredible. But it is impressive. I mean, if you compare this to anything remotely modern, it's horrible. But the fact that this is a simple, very early DOS machine that's able to handle upwards of 4 to 5 HTTP connections, I mean, that's not bad. Okay, so I wanted to try out the web server that comes with MTCP. So we're going to need to modify the configuration file. So to do that, I'm going to consult the sample configuration that's on my main system here. And we'll use our good old friend Edlin again. Let's see, we want to do line 7 and input. And so we're going to say HTTP, we'll just do it in caps. And we'll say this is www. On the next line, and we'll just say log. And finally, We'll just have that to no for now. Okay, and then we'll write. Excellent. So now if we take a look at the config, yeah, we have those in there. So I think we can go ahead and start the server. Actually, I need to actually make a web directory, and let's create a file here. Okay, there we go. Gotta remember all my HTML. Okay, and then we'll have a center tag here and welcome. Okay, so we have our index.html file. And now I think we can just go ahead and start up the web server. Oh yeah, fantastic. It's running. Wow. Okay, so let's try. Yeah, I would say let's go ahead and try to do the load testing on this one just to see if there's any difference. So we're going to try the Apache bench test again. And so let's do 30 since it took so long last time, and we'll do a concurrency of 10 just to see how many it can get concurrently. And let's get it started. Wow, much, much faster. Yeah, we're seeing 6.3 requests per second. Wow, so I wonder if that other program, EasyNOS, is just not really optimized for slower systems. This seems much better. So let's bump this up to 100. And we'll keep concurrency at 10, and I'll keep a better eye on this. So active connections 5, 6. We're up to 7, 8. Yeah, we peaked at 8. Wow, so that's really not too bad. So let's try bumping this up to, we'll do 300. We'll put in another 5 to see if we get any difference here. Okay, we're up to 8 active. Yeah, topped out around 8 active. Yeah, so our request per second really dropped off there. If we bring this back down to something like 5. Yeah, it's much better. So as soon as we put the concurrency up to 15, it really took a dive. Yeah, you can see our request per second drastically improved. Well, that about does it for what I wanted to accomplish on the Model 25. I never expected getting it online to be this much fun, and there's still so much left that can be done. We'd love to hear about your experiences getting these old machines online, so please drop your stories in the comments below. And thank you so much for watching, and we'll see you next time.